So question 152, another big integration question. So let's get going. So the first part of the question is to use the trapezium rule with 5 strips. And we're going from 0 to pi. So that means our x values are evenly spread between 0 and pi. Each strip has got a width of pi over 5. So I'm drawing up a table here with the values of x going from 0 to pi in increments of pi over 5. And then for each value of pi, I'm working out what the value of e to the 0.5x cos 0.25x is. And of course, I'm in radians. So I'm writing the answers here to 5 decimal places. Because I want to make sure that my answer is correct at the end to 3 decimal places. So then putting those numbers into the formula for trapezium rule, the value of the integral is approximately equal to a half. H is the width of each strip. And then we've got the first value here, which is 1. The last value there, and then 2 lots of all of the others added together. So when we put that into our calculator, we get this number here, which I'm retaining 5 decimal places in that number because when we move later on to look at the percentage error, I'm going to be using a more accurate value of that estimate. But for now, to answer the question, 3 decimal places, that's the answer. So now we have to find the exact value of the integral. So for the moment, I'm going to define I to be this integral but without the limits. So I'm just going to ignore the limits for the moment because I just want to simplify this a little bit. It's difficult enough without the limits for the moment. So if the integral I is this one, then I've got 2 functions being multiplied together. I can use integration by parts. And it doesn't really matter too much which one I choose to be the u and which one I choose to be dv dx. So I'm choosing them this way round. So if u is e to the 0.5x and du dx, we just multiply e to the 0.5x by 0.5. And then dv dx is cos 0.25x. So v is sine of 0.25x divided by 0.25, which is the same as multiplying by 4. So v is 4 sine 0.25x. If you're not very confident on your integration of cos 0.25x, then you might need to integrate that separately using a substitution of u equals 0.25x. Okay, so putting those things into the formula for integration by parts, we get uv minus the integral of v du dx. So there's our uv, and then the integral of v du dx. Well, on the face of it, it looks as if we haven't really made much progress because the integral that we've ended up with doesn't look, in fact, it looks worse than the one we started with. But if we persevere and we look at this integral separately now, then we might succeed. So looking at this integral separately, the integral of 2e to the 0.5x sine 0.25x, again we've got a function multiplied by a function, so I can say one is u and one is dv dx and use integration by parts. So there's my choice of u and dv dx. And if u is 2e to the 0.5x, then du dx is just e to the 0.5x. And similarly to above, if dv dx is sine 0.25x, v is minus cos 0.25x divided by 0.25, which is minus 4 cos 0.25x. So putting those things into the integration by parts formula, I get this expression for the integral of 2e to the 0.5x sine 0.25x. I'm just going to tidy that up, and also I'm going to notice that the integral of e to the 0.25x cos 0.25x, that is the same as the integral I started with. So we've also got minus and minus, which is plus. So this here is the same as 4i. All right. So if we've run out of space now. So if we take these two expressions here, one for I itself, and then one here for the second part of I, put those on the next sheet, then we can see that I, if we combine these two together, the I is that minus this. So minus 8 is plus 8, and minus 4i is minus 4i. So now we're starting to get somewhere, because we can now take this minus 4i over to the other side. It gives us 5i. So we've got an expression for 5 times the integral. Dividing that by 5 gives us an expression for I, the integral of this without any limits. I can tidy that up a little bit, factorising out the 4/5 e to the 0.5x, and then inside the brackets I've got sine 0.25x plus 2 cos 0.25x. Ready to come back to our original integral, which is the integral from 0 to pi of I, so we've just really got to substitute the limits in now. So the first limit, the upper limit, is pi, and the lower limit is 0. So when I substitute the upper limit in of pi, I get pi here, here, and here. And the sine of 0.25 pi over 4, is root 2 over 2. And so is the cos of 0.25 pi. So that's where these root 2 over 2's come from. This is 2 root 2 over 2 because of that 2 there. When I substitute the lower limit of 0 into here, the sine of 0 becomes 0, but the cos of 0 is 1. So I'm left with 2 there, because it's 2 times 1. Bringing that all together gives me this expression, and that would be enough to get the answers. It's in the answer mark. It's in exact form, but I want to tidy this up. I don't like having two denominators here, so I'm going to multiply the I'm going to express 4 as 2 times 2, and then multiply one of these 2's into the bracket, and then I get that expression, which, if you multiply this out, is the same as that. Okay, so that's the answer to the part where we've got to find the exact value of the integral. We've still got to find the error, the percentage error, in the estimate. So the formula I'm using for percentage error is this one, the estimate minus actual divided by actual. And the estimate, if you remember, I'm using the 5-digit number for the estimate, and then the actual figure we've just seen on the previous slide. And we pop that all into the calculator. Goodness knows how the calculator finds the value of that, but it does. And it gives us the answer of 0.18% to two significant figures. I hope that's correct. All right, if you got that far, then well done.